Hello, I am Dr. Valentín Vassilev Galindo, an MSCA researcher at the Materials Institute. This is the second episode of our HIGHHYDROGENML Science Explained series. In our previous video, we spoke about machine learning, how it works, and the role it can play in materials discovery. In this episode, we will talk about computational chemistry. Stay tuned. The typical image of a chemist is that of a person mixing substances in flasks wearing a lab coat. However, there is another type of chemist that only works with computers, the theoretical and computational chemist. Computational chemistry is a branch of chemistry that uses computers to study chemical systems. It is used to explore physical and chemical processes, defining the structure, properties, and interactions of molecules. For instance, one can model chemical reactions, binding on drugs, or obtain thermodynamic properties of molecules and materials. All of this is done by solving the Schrödinger equation. Although it looks very simple, this equation is actually really hard to solve. In fact, this can only be done exactly for one electron system, such as the hydrogen atom. For everything else, we need to resort to approximations to find a solution. This gives rise to several methods, such as wave function theory methods, density functional theory, semi-empirical methods, and classical force fields. The highest quality methods provide very accurate results, as good as 1 kcal per mole compared to experiments, but also demand a high computational cost. Given the computational requirements of the most accurate methods, computational chemistry calculations are usually carried out on high-performance computers, made up of several computing nodes. Each of the nodes of such computers have the same computing power as several typical desktop computers. Despite the current availability of huge computational resources, some computational chemistry applications are not achievable due to their immense computational cost. In such cases, scientists leverage machine learning approaches trained on relevant data in order to obtain accurate predictions at a fraction of the cost. It is precisely the synergy of machine learning and computational chemistry that has revolutionized the field in the last decade, improving the applications to a new level. In the HIGHHYDROGENML project, we are using computational chemistry to explore more affordable and better performing catalysts for use in hydrogen production and clean energy generation. But how and why? That's what we are going to explore in our next 2 episodes. This has been HIGHHYDROGENML Science Explained. I am Dr. Valentín Vassilev Galindo from the Materials Institute. I'll see you in the next video.